Now find the next two terms of the sequence. Find the next two terms of the sequence. Now, sequence can be divided into two parts. We called one the arithmetic progression, then the other one is geometry progression. Now, depending on the way the sequence is, so if it has a common difference, we call it an arithmetic progression. If it has a common ratio, then it is a geometry progression. You can also have a decreasing and an increasing sequence. Now, this first one here, you can see this 3 is called the first term. The first term. Then this is the second term. You can call it T2. Okay. This first term T1, or most of the time we use A to represent it. So we have this as third term, fourth term, fifth term, and so on and so forth. So you just look at the rule connecting the terms. Now in this case, you can see that we have a difference of 4 between 7 and 3. So you move to the next two, terms. So can you have a difference of the same number? So you have 11 minus 7 will still also give me a difference of 4. 15 and 11 also a difference of 4. Then you realize that we have a common difference of 4. When you have a common difference in a sequence, that kind of sequence leads to arithmetic progression. So this first sequence is an arithmetic progression, and it's an increasing sequence, an increasing arithmetic progression. So you can see the number tends to increase by 4. So of course, for me to now get this empty space here, it means I have to add the common difference, which is 4. Solution. So we had a common difference. We have the first term. We have the first term A. That's the first term. Same as saying T1. That is equal to 3. Okay. Now, so for me to get, let's say T2 now. T2, I'm going to say 3 plus 4. Okay, and that gives 7, because the common difference equal to 7 minus 3. That is T2 minus T1 will give me the common difference. Or it's just saying T3 minus T2. So that implies that for me to get this dash, it means I have to add 4 to 19. 19 plus 4 will definitely give me 23. So this part of it is 23. Then to get this next one, I'll do the same thing. 23 plus 4, and that gives 27. So this 27 is an AP. An AP. Now we move to the next one. We have 50, we have 40, we have 30, 20, 10. The next one. So you just look at it again. Now the difference between 4 and 50. Alright, this if you look at it, this a decreasing sequence, but let's see if it's an arithmetic progression or geometry progression. So how can we get that? You just look for the common difference. Now B, we have using the same formula here, you have the difference to be equal to T2 minus T1. By T2 in this case, second term is 40. So I just say 40 minus 50, and that gives a negative 10. So if the difference gives negative, it then implies that it's a decreasing sequence. It's a decreasing sequence. So what will I do to this 10? I'm going to add minus 10. You add minus 10 to this 10 to get the next one. Or another way of saying it, you take away 10 from 10. You subtract, because this 40 is got to by saying 50 minus 40. 50 minus 10, I mean, to get 40. 40 minus 10. So you take away 10 from each of this term to get the next one. Okay, so to now get this one, I'll just say 10. Normally should be, let's just say plus minus 10. So just for you to understand better. So we have that as the 10 plus times minus is minus 10. and that gives a 0. So the next time here is 0. So to get this other one, I'm going to do the same thing. 0 plus minus 10. So that is 0 minus 10, and that gives minus 10. So this is minus 10. So this is also an arithmetic progression, only that it is a decreasing arithmetic progression. It's an arithmetic progression because we have a common difference between the term. Now the question C now, let's look at that. So we have 4 minus 1 minus 6, no, minus 11 minus 16. Now you just look at it, you say, let me test if this is an arithmetic progression. Let's see if there is a common difference. We have minus 1 minus 4. That is the second term minus the first term. So I realize that this one gives minus 5. So let me test it. Let me test these two again. So difference, let's see, minus 6 minus 1. Because this difference, minus 6 minus 1. So this will give me minus 6 plus 1. And of course, I realize that minus 6 plus 1 also gives minus 5. It means there is a common difference of minus 5, but it's also a decreasing sequence because the difference is a negative. So to now get this one, I'm going to say minus 16 um, minus 16 plus minus 5 plus minus 5. Or another way of doing it, just minus 16 minus 5. Because plus times minus will give me minus, and that gives a minus and that gives minus 21. I'm sorry for that. Minus 21. You have minus 1 minus 4. That's minus 5. So D equal to for using the second sequence. Using the second sequence here, I mean this the other two terms. So minus 6 minus 1 minus 6 minus 1 here, give minus 6 plus 1. So we have that as minus 5. So to now get this other one, then I'm going to say minus 16 minus 1 minus 5, or minus 16 plus minus 5, and that's what I wrote here. Minus 16 plus minus 5, and that's equal to minus 16 minus 5. I have that as minus 21. So this other term here is set to minus 21 minus 5. That gives minus 26. So we have minus 26. So this is also an arithmetic progression, decreasing arithmetic progression. Then the next one here, let's look at it. Now we have uh, 5. We have 5, 15, 45, 135. Now let me just test for common difference. Okay, common difference. Let's say D. For we have 15 minus 5. That gives 10 difference. The next one we have D equals 45 minus 15. I realize that this is what 30. So there's nothing like a common difference in this case. The difference is not common. So this is not an arithmetic progression. Then we now move to common ratio R. Now to get the common ratio, I'm going to say T2 divided by T1. Let's see that for the first two terms. So T2 is 15. 15 divided by 5. 15 divided by 5. 5 here, 1, 5 here, 3. Okay, we have 3 in that case. Now let's pick the second and the third term too. We have ratio as 45, divided by 15. So I now realize that 15 here or 15 here 3. So we have the same result. This one gives a geometric progression, GP, geometric progression. Okay, now that we have a geometric progression, so it means this 50 is gotten by saying 5 times 3. So you multiply the term, by the common, you multiply the term by the common ratio. Multiply the term by the common ratio to get the next one. So say 5 times 3, you have 15. 15 times 3, you have a 45. 45 times 3, you have 135. So definitely 135 times 3 will give me this one here. Okay, so unlike this one, this arithmetic progression that we have to add, then this one you have to multiply, and that's why we call it a geometric progression. So to get, the next time we have 135, times 3. Okay, so 135 times 3 equal to 405. 405. So we have this as 405. The next one, 405 times 3 will give me, 405 times 3 equal to 1215. Okay, they have conveniently write it here, 1215. That's for GP. Okay, now the next one here, can you see that too? So that's E. Then let me just test. Let me test for, because the way I'm looking at this should be a geometric progression. So you have ratio to be equals to 9/27. Now here 1, now here 3. Can you see that? So the next one, let me just say r equals to 3/9. We still have the same result. 3 here 1, 3 here 3. So we have 1/3 in that case. So it's also what? A geometric progression, because we have a common ratio. So what will I do to get 27? I multiply by 1/3, and then I'll get 9. 9 times 1/3 will give me 3. 3 times 1/3 will give me 1. Then 1 times 1/3. Or you can say 3 divided by 3. 9 divided by 3. 27 divided by 3. So to get this one, I'm going to say 1 times 1/3, and that gives 1/3. So this one here is 1/3. Okay, so we also have the next one to be 1/3 times 1/3. That gives 1/9. So this is 1/9. 1/9. So if there's any question, that's all. So if there's any question, so you let me know in the comment section. So I'm ready to answer all your questions. All right. So this, before I forget, this decreasing geometric progression. Alright, so we have a formula for calculating the terms of an arithmetic progression, and that of GP2 is different from arithmetic progression. So as we move on, you understand better. Thank you.